Hi, this video is about Isaac Newton's second law. So a previous video we talked about Newton's first law. Newton's first law basically says that if there's no net force exerting its force on a body, then that body will have zero acceleration. Or the popular way to put it is, a body at rest wants to stay at rest, and a body in motion wants to stay in motion. Unless there's some force, a net force on the body, it's going to stay in whatever state it's in. Now, so Newton's second law follows directly upon that. If there is a net force, there's going to be an acceleration. So the default state is, Newton's first law, body at rest is going to stay at rest, body in motion is going to stay in motion. But if there is a force, a net force on a body, there is going to be acceleration. And remember, acceleration could be positive, getting faster, or it can be negative, getting slower, or it can be changing direction. But if there is a force, it will, in fact, accelerate in some way. And the magnitude, this is something that Isaac Newton discovered in the 1600s, that the magnitude of that acceleration is going to be directly proportional to the magnitude of the net force. In other words, as the force goes up, the acceleration goes up, and as the force goes down, the acceleration goes down. And so usually in such cases, we look to find some kind of a constant, some kind of amount that we multiply the one or the other by in order for it to be an equal sign rather than just proportion. And the winner is F equals ma. So force equals mass times acceleration. So if you want some simple way to remember Newton's first and second laws, his first law is body at motion wants to stay in motion, a body at rest wants to stay in rest. And his second law is F equals ma, where F is the force, A is the acceleration, and M is the mass. So it turns out that the mass is the constant that binds the force with the acceleration. Or, to put it in summation notation, the sum of all the forces, that is the net forces, the net force equals the mass times the acceleration. We can also put it in words rather than funky symbols we've learned in math class. We can say that 1 Newton, and cleverly named after the guy that kind of codified all this, 1 Newton is the amount of net force that gives an acceleration of 1 meter per second squared to a body with a mass of 1 kilogram. So the unit of force most of the time is a Newton, and 1 Newton is 1 kilogram meter per second squared, because by definition 1 Newton of force is the amount of force it takes to make 1 kilogram of mass to accelerate by 1 meter per second. By the way, there are units in the English system. So pounds, actually pounds, is a force, abbreviated LBS, or LB for 1 pound. In the English system, 1 pound is 1 slug foot per second, where a slug is technically the unit of mass. But I'm going to stop there. Maybe in the next video on mass and weight, I'll go into slugs, cleverly named or not so cleverly named. Anyway, not important. So the unit in science these days of force is the Newton, and it's 1 kilogram meter per second squared. Now, this section ends with some clarifications. So first of all, F equals ma, it's a vector equation. That means it involves a specific direction. And the direction of the acceleration is going to be the same as the direction of the net force. Okay? Check. Second clarification. Newton's law relates to external forces, that is, forces on the body from the outside, not internal forces. It has to do with the external forces when we talk about the net force and so forth. Third, this equation works with a constant mass. If the mass is varying, things are going to get complicated, and we're going to have to move to much more advanced kind of physics. But we're only in the early chapters of this physics book. By the way, this video is keyed to Young and Freedman's University Physics, chapter 4, I believe it is, section 3, I believe it is. But any physics textbook is going to deal with Newton's second law. Next, the law, this is only valid within a particular inertial frame of reference, which we've discussed in a previous video. Okay, and a frame of reference is basically any kind of XYZ time system, and we call it an inertial frame of reference if Newton's first law works in it. And this is F equals ma, Newton's second law, a short video by Ken Schenk.